Okay, good morning. Ion exchange chromatography. Ion exchange chromatography is a process by which a mixture of similar charged ions can be separated by using an ion exchange reagent which exchange ions according to their relative affinities. It is a process that allows the separation of ions and polar molecules based on their charge. A form of liquid chromatography in which the stationary phase is an ion exchange reagent, which may be cation exchange reagent or anion exchange reagent. It can be used for almost any kind of charged molecules, including large proteins, small nucleotides, and amino acids. Ion exchange chromatography is a process by which a mixture of similar charged ions can be separated by using an ion exchange reagent which exchanges ions according to their relative affinities. Principle of ion exchange chromatography. It is a chromatography process that separates ions and polar molecules based on their affinity to the ion exchanger. The process of removing observed ions is known as elution. The solution employed for elution is called eluent, and the solution obtained from elution is called eluate. The liquid flowing into another, that is, the liquid entering the ion exchange column, is called effluent, and liquid leaving the column convent is called effluent. Reversible exchange of ions between ions present in solution and ion exchange reagent. Cation exchange chromatography, positively charged proteins are reversibly adsorbed to immobilize negatively charged base polymers. Cation exchange chromatography, positively charged proteins are reversibly adsorbed to immobilize negatively charged beds of polymers. Anion exchange chromatography, negatively charged proteins are reversibly adsorbed to immobilize positively charged base polymers. Cation exchange reagent, anion exchange reagent. Cation exchange reagent, cation exchangers. The cation exchangers The cation exchangers have negatively charged with positively charged mobile counter ion available for exchange. For example, sulfonic acid, strong cation exchangers, carboxylic acid, weak cation exchangers, cation exchange resin, cation exchange solvent, resin. A typical example is displacement of mobile ions from DOX50 sulfonated polystyrene cation resin by calcium ions. Sulfonated cation exchange resin. By passing a solution containing sodium ions, the calcium ions may be removed from the resin and the original sodium form of resin is generated. Anion exchange resins, anion exchanger. The anion exchangers have positively charged exchanger, which negatively charged mobile counter-ion available for exchange. For example, quaternary ammonium polystyrene. Anion exchanger, cation exchanger. Anion exchanger, they contain immobilized cationic groups that bind to the anions. They contain immobilized anionic groups that bind to cations. Anion exchanger, the most common are matrix with attached diethyl aminoethyl. For example, a cation exchanger matrix with carboxymethyl group. Application of ion exchange chromatography. Ion exchange chromatography is used for the separation of rare earth metals, amino acids, carbohydrates, proteins, transition elements, complex ions, and even isotopes. What are the ion exchange resin? Write down the structure of any one of them. Cite an example of where ion exchange resins are used separation of metals. Or what are the ion exchange resin? Describe cation exchange resin and anion exchange resin with example. Ion exchange resins are highly polymerized cross-linked organic substances containing a large number of acidic or basic groups as active site. These acidic or basic groups are capable of undergoing exchange with other ions. All ion exchange resins are almost insoluble in water and organic solvents. Depending on the nature of active site present on ion exchange resin, they are classified into two ways. Ion exchange resin is a small porous bead-like polymer material that removes unwanted ions from water or other solutions and replace them with more desirable ions. Or ion exchange resins are highly polymerized cross-linked organic substances containing a large number of acidic or basic groups as active sites. So, acidic or basic groups are capable of undergoing the exchange with other ions reversibly. All ion exchange reagents are almost insoluble in water in organic solvents. Cation exchange reagent. These reagents contain acidic groups such as carboxylic, sulfonic, phenolic, etc. as active site. These reagents contain equivalent number of cations, Na plus, S plus, etc., which can reversibly undergo exchange with other cations. For example, sodium polystyrene sulfonate can exchange cations and hence acts as cation exchanger. These reagents act in metal ions as figure a strongly acidic sulfonate polystyrene cation exchange reagent. Uh, Resin have the H plus and Na plus. The H plus is exchange. In another example, the magnesium also exchange with the resin. Anion exchange resin, these resins contain basic groups such as amines, quaternary ammonium groups with equivalent number of anions such as hydroxyl as active site. These resins can reversibly exchange other ions from solution. For example, tetramethyl ammonium groups can exchange anion and hence act as anion exchanger. Example strongly basic quaternary ammonium ion exchange resin. Exchange of chloride ion, exchange of sulfonate ion. Principle of an ion exchange chromatography. Give an example along with the working principle of an ion exchange method for separation and purification of metals. What is the principle of ion exchange chromatography? Give an example of ion exchange method used for separating metals. The ion exchange chromatography is based on the fact that different ions have different affinity to undergo exchange with given ion exchanger. The ability of ions to undergo exchange with active site of an exchanger depends on the size and charge of ions to be exchanged. The ions having the small size and high charge are exchanged rapidly, while those having large size and low charge are exchanged slowly on the ion exchanger. The exchange ability of different metal cations decreases in order. The solution containing mixture of ions is passed through the suitable ion exchanger. The ions having the small size and high charge is held at the top, while the ions having the large size and low charge are held further down the column. The ions having the large size and low charge are eluted first, followed by the other ions having the small size and higher charge. Column with the cation exchange resin. Uses of ion exchange resin. It is widely used in water purification, water softening, wastewater treatment, pharmaceutical production, food processing, power plants, boiler feed, water treatment. Ion exchange chromatography is used separation of lanthanides. Uses of ion exchange resin in separation and purification of metals. The solution containing mixtures of ions is passed through suitable ion exchanger. The ions having the small size in high charge are held at the top, while ions having the larger size in low charge are held further down the column. The complete separation of ions is imposed by passing the suitable solvent through the column. The ions having the large size in low charge are eluted, first followed by the other ions having smaller size in higher charge. For example, when a solution containing mixture of lithium, sodium, potassium, rubidium, cesium ions is passed through the ion exchange reagent, cesium ion is eluted first from the column, followed by the lithium, sodium, potassium, and rubidium. Uses of ion exchange bit method for separation of the lanthanide elements. Ion exchange is the most important and rapid method for the separation and purification of lanthanide elements. In this method, synthetic ion exchange resin such as Dowex 50 is used, which is the cation exchange resin. When the solution containing the mixture of ions is passed through the column, the ions exchange with the hydrogen ion of the resin. Lanthanides, hydride ion, resin. Uh, Complete separation of lanthanide ions is imposed by passing the buffered solution of citric acid at pH 8. The following equilibrium is set up. Lanthanide resin. As the solution of citrate run down the column, lanthanide ions are eluted in the form of citrate complex. The smaller lanthanide ions are eluted first through the column, followed by the next larger ions.